Welcome back, guys. Patrick here. Moving on to the next question. We have to find the degree of this expression here. So we got 1 plus xy to the power of 3 times x plus x squared y to the power of 4 times x plus y squared. So this one is a little bit tricky. So what you got to do is pretend like we expand all this, and then the degree is going to be the highest exponent number. So for example, if we had like x to the 4, y to the 3 plus x to the 5, y to the 1 minus x to the 7, y to the 2, right? Let's pretend we expanded this and we ended up with this. Well, what's the highest exponent going to be? We would have to add these. This would be 7, this would be 6, this would be 9. And you could have other terms. You could have like minus x by itself, so that would just be 1, minus a constant maybe, like 5. That would be, there would be no exponent on that. It would be like x to the 0, y to the 0, right? So that would have a degree of 0. Then you look at all these, and then 9 is the highest. So the degree of this expression is 9. So what we got to do is we got to expand this and then figure out what's the degree going to be. Problem is that notice that if we try to expand this, like if we try to FOIL it out, even if we use the Pascal's triangle on this, is going to take us a very long time because of this 3 and then because of this 4. But what we can do, a quicker way to do it, is we could take each bracket and we could just take the expression that has the highest degree inside that factor, inside that bracket. So notice between 1 and x1, y1, this has a degree of 2, right? So we could take just that, take it to the exponent 3. Between x and x squared y, well, this would have the highest degree in that bracket. So we'd have x squared y, that would be to the power of 4. And then between x and y squared, the highest degree would be y squared, like that. And so now what we can do is we can just multiply these, and this here is going to give us that expression in the expanded form of this that's going to have the highest degree, because we took the highest degree from each of these brackets and now we're going to be multiplying them, because eventually if we were to expand this, those highest terms would multiply by each other like this. And we only care about those highest degree terms. We don't care about the rest of the terms because we're just trying to find the overall degree. And so from here now, you can just simplify this. So this, you'd distribute the 3 in. Here, we would distribute the 4 into both of these terms, and then the y squared is just by itself. So what, we'd have x3, y3, multiply these. This would be x8, y4, y2. And now x3, x to the 8, if we multiply those, they have the same base, so we could add the exponents. 3, 4, 2, that would give us 9. Sorry, this would be y. My bad. Right, like that. And so this here would end up being the term in this expanded form that has the highest exponents, or has the highest sum of the exponents. The sum of the exponents is going to be 20. So the degree of this expression is 20, which would make the degree of this expression be 20 as well. Right? So the final answer is 20. So when you get something like this, you could just take the highest degree terms in the brackets and then just take them to whatever power is on the outside. And sometimes it's going to be tougher to find out, like this is 3 and maybe this would be like, let's say 1 and y to the 3. Sometimes it's hard to see. So if we had something like this, this would be the higher degree, the x, y to the 3, because this would have a degree of 3, this would have a degree of 4, so then we would take this term and put it here and take it to the power of 4, right? So just be careful within the factors that you're getting that highest degree term, and then you just have to work with that single term inside the brackets, simplify it, and then you get the degree of the overall expression.